Right, so welcome everybody. Thank you for staying almost to the end of the second day. I have a small confession to make, which is that I'm a little bit out of my comfort zone here. Because I normally speak to a Scala audience, and you can see up here that I'm claiming to disrupt the Scala ecosystem. But the things I'm going to talk about today, which is a build tool I've been writing called Fury, apply equally to Java, potentially Kotlin, and maybe even could be extended to other languages as well. So although I've come at this problem from a Scala perspective, which is my background, and I've spent the last nearly 15 years working with Scala, you can think of some of the things I will talk about in maybe a broader sense, maybe in the languages that you use as well. So just out of interest, how many people here are using Scala at the moment? It is probably a mere 5% of you, not very many. How many people here are using a JVM language? Oh, good, okay. So I'll be talking about some JVM concepts like class paths and compilation. So Fury is a build tool in some sense, like SBT, which Scala users will be familiar with, or equally Maven. But it's also a dependency manager. And of these two roles it has, I think actually the dependency management is perhaps more interesting and has some more unique ideas. I've also come at this very much as a response to SBT. Now, I don't know of the people who are not writing Scala have maybe heard of SBT. How many people here have heard bad things about SBT? So its reputation is probably just a little bit greater, or its bad reputation is a little bit greater than the Scala community itself. So I've tried to respond to some of the criticisms of SBT in the development of Fury. So let me try and explain a little bit about what Fury is and in particular what makes it different. Now, one thing I always try to do with any projects I work on is try to look beyond the most immediate problems and the causes of the most immediate problems and try to find what the root cause is. And that often leads to me exploring somewhat more radical ideas. And actually, I'm rarely interested in a project unless it goes deeper and tries to be innovative in some way. So one thing which Fury does differently from SBT is to use a purely static data format for representing builds. If you use SBT, you will know that you actually write code, and then you compile that code, and then you run the code. And I've decided to go against that approach and to use data instead. Fury prefers not to use binaries. It prefers source dependencies, Git repositories with commit hashes in preference to binaries that you maybe download from Maven Central. And there's no build file. Well, there is a file which stores details of the build, which stores the data format, but you don't edit the file. You don't open it up in a text editor. You run commands, much as you run Git commands from the command line, to interact with that file and mutate it. So let's look at each of these things in turn. So there is a model which represents, or attempts at least, to represent all possible builds for Scala applications. And this build tries to capture all of the relevant details, the order of compilation, the names of things, the dependencies between them. So there's a model, it's an ADT that represents that. And for me, the biggest benefit of this is that our dependency graph is not written in some Turing-complete language. We don't have to go through this process of compilation and then running the code, which is slow, especially with Scala. Scala is a slow language to compile. We don't have to go through this process just to work out what the build is going to do. We have the graph, we have the dependency graph right there. because it's simply a data format. And we can reason about it. We can reason about it fast, and we can analyze it. We don't need to do any compilation and running. So this makes Fury responsive. It's very fast. Most operations are instantaneous. I chose to use source dependencies, and builds can depend on a Git repository and a particular commit hash. They can depend on a branch as well, but when you publish a build, it's always tied to an exact commit hash, so there's no risk that the branch moves on and the build breaks. If the build was successful when you ran it, when you published it, it will remain forever successful because it will always depend on a commit hash. The biggest benefit of this, I think, is that we don't have to wait for binaries to be published. Now, if you've published Scala or Java programs to Maven Central, actually, how many people have done that? How many people have published anything to Maven Central? Now, keep your hands up. How many people found it easy? They've all gone down, I think. So, it's kind of hard. You have to go through quite a long-winded process, and a lot of people fail, I think. It took me a year to publish my first thing to Maven Central, and by the time I finally got it out the door, the world had moved on and people weren't interested. That was a few years ago now. But it's kind of a slow process. Oh, there's some tumbleweed rolling across the floor. I don't know if you can see it. And you can't publish a binary unless everything you depend on has also been published. So you have to wait for other authors to publish their software before you can publish yours. And if all of those other authors are slow or they're going through the same problems you are to get things onto Maven Central, that slows everything down. And the depth of the tree is somewhat proportional to the length of time it takes to publish your software. And if you're using Scala, Scala has a new release every couple of years, and it requires, because there are breaking changes in each release, it requires the entire ecosystem to be republished. And it can be months after the original new Scala release before some projects actually become available as binaries. This is too slow. In particular, there's a project called Scala.js, which almost every project in the ecosystem depends on. Now, Scala.js was a PhD project from a guy called Sebastian Duren. And as a PhD student, he knew that the entire ecosystem depended on him, more or less. So think of the Scala ecosystem. I don't know if it's worth multi-billions, but it's certainly hundreds of millions of dollars worth of industry going on there, depending on a PhD student to publish a library. And what he would do is he would make sure he didn't schedule vacation for when a Scala release was happening. So he'd be in contact with the people who published Scala. He would make sure that he had it was scheduled into his calendar, and he would make sure he wasn't out of the country or he was at his computer when that needed to happen. Because otherwise he's holding up the whole ecosystem. For me, that seems completely wrong. There shouldn't be such a burden on any open source developer who's committing their time and effort to providing something for other people. By using source dependencies, and another feature of Fury is that it allows the build definitions to be stored outside of the project itself. So I can include in a build external sources, and I can publish that, whether or not I'm the maintainer of that particular library. And this is going to be great for bootstrapping the ecosystem. It means that I don't need to persuade every single maintainer of every single project to adopt my build system rather than SBT or anything else. Because all I need to do is persuade a small group of people who, between us, can help publish builds for other projects. We can bootstrap, and a large part of that ecosystem can be published with Fury. And because whenever we define a build, we have the source available to us, we're depending on sources, we can use the compiler to check that everything is compatible. The sources are never separated from the binaries as they are with Maven Central. When you publish via Maven Central, you have the sources, you compile, you publish, and then the person who gets that binary no longer has access to the sources. So what build tools like Maven do and SBT is sometimes they have to pull in slightly different versions of the same library. Or there are two different libraries which have slightly different dependencies on different versions of the same library. And what Maven and SBT will do is they'll silently upgrade to the most recent version and just hope, and it is hope, that they still link correctly. Now, I don't know about you, a lot of you are obviously Java developers, but I like to have the compiler checking everything for me. I like my errors at compile time, not at runtime. And by silently upgrading to a version that's different from the one it was compiled with, we're risking linking errors. Class not found, no such method errors. That's something we don't have when the source is never separated from the binary. Fury has a Commandant Interface. Now, I'll show this in a little bit, but we interact by typing commands into the shell, and they typically mutate a build file. And the build file is stored in the Git repository in all cases, and we can track the changes. There's also a lot of effort I've put into the user experience of using Fury. It has colorful output, which is not only nice to look at, but it's indicative of the information you're showing. So whenever you see a project, that will always be the same color. Whenever you see a module, that would be a different color. Whenever you see a repository, that'll be another color. So you start to learn what things are. You start to understand very quickly if you see something, some identifier, by looking at the color, you can glean a little bit more about what it's representing. And probably my favorite feature is that it has tab completion. This makes it very easy to run the commands and get suggestions as to what the completions might be. So what is it like to actually use Fury? I'll just show you a few commands here. We can create a new project, Fury project add, and we give it a name. Magnolia is a project I've also developed for Scala, so this is how I would create that project. And within a project, you have modules. So we can create a core module, and that goes inside the Magnolia project. We can pull in a source repository. So I'm defining this build from scratch, but I need some sources to compile. So I'm going to pull in the source repository here. I'm going to give it the name Magnolia, and I'm going to use this shorthand. GH is GitHub, so we don't need to write git at github.com : and so on with a .git at the end. You can just use this shorthand and it'll get expanded. And having pulled in those sources, we need to associate just some directory in the source with a module that we're going to build. By the way, I'll explain projects and modules and workspaces a little bit later. For now, hopefully you get some sort of idea as to what the meanings are. And we probably want to make a change to the module, so we can specify that we're going to compile it with the Scala compiler rather than Java, which is the default. And to compile it, you just run Fury. So I'm going to do a very quick demo somewhere over here. There we are. So this is a directory which contains a Fury build, and I can list the modules, and you see we get tab completion here to help me remember what each thing does. If I list the modules, we get this table here that if I scroll up, lists the module, the type of module. They're typically libraries, the dependencies it has, where the sources come from, and you can see all the colors are different depending on whether it's a project, module, repository, or path, whether it has binaries, what compiler it's using, and whether there are parameters. So this is some sort of definition of the modules in Fury. It's actually a bit bigger, so we can actually show a list of the projects that are defined here. Let me put that up there. So these are projects defined in my workspace. Each project has several modules inside it. And if I want to run it, if I want to run the build, I just type Fury, and hopefully it will draw a nice graph for me. And the modules you can see highlighted there are the ones that are currently being compiled. Now you see, Scala is still quite slow. It got through the first 20 or so pretty quickly, but Fury Core is a big one. And then it's doing these 4 in parallel. You can see on the right-hand side there's little green stars appearing. If you're at the front, you can probably hear my laptop is getting warm. The fan started. And finally, we finished building Fury and all of its dependencies from source in 27 seconds. So that's the sort of user experience of running a compilation. Does it look nice?
That was great.
Cool, thank you. Now, what I've described up to this point has been mainly creating a sort of empty project from scratch, but we often need to depend on other projects. So if we wanted to depend on another library, so take Shapeless, for example, which is a very commonly used library in the Scala ecosystem, we can run these 3 commands. I'll just very briefly talk through them. First of all, we add the repository, very much as we did before, but this is a repository that points to another workspace. So we're working in our own workspace, and we want to actually pull in this workspace, the Shapeless workspace, into our own workspace. Now, pulling in a workspace makes available all of the projects defined in that workspace to us, so we can then depend on them. So first I add the repository, then I import it. That's what brings the projects in. And having done that, I can add a dependency on Shapeless core. So my module now depends on the core module of the Shapeless project, which was defined in the Shapeless workspace, which I imported. And I imported the Scala 212 schema of that. I'll talk about schemas later, but I'm sort of deliberately using the terminology without fully explaining it, hoping that you kind of get some idea as to what it means. We can also, having pulled in that Shapeless repository, the project in fact, if we wanted to modify the Shapeless sources as part of our project, say we discovered a bug in Shapeless and we wanted to try and fix it, because if we're open source contributors, we want to contribute back if we can. And we discover a bug in an open source library, it would be nice if we could just go and fix that ourselves and contribute it back to the community. It's not necessarily the best solution. If somebody else does it for you, that's easier, but often we really need to make progress, and fixing someone else's source is often the only solution we have. But if you were working with binaries, what you would have to do is first of all work out what source corresponds to the binary you're using. And then you would go and probably clone the repository. You would attempt to make the changes, and if you're using Maven or SBT, you would then have to publish locally a snapshot of Shapeless, in this case, with the changes you've made. And then you would edit your build to point at the snapshot instead of the binary that's on Maven Central, and you could test things out. And if it works, great. If it doesn't, you go back, you repeat, and it can be quite a slow process. You have to rewrite the build every single time, and it's kind of slow and kind of painful. Now with Fury, you have the sources there. When you import a project like Shapeless, first of all, it's managed in a hidden directory, so you don't normally see them. But often you would like to pull those sources out of the managed area and just onto somewhere on your hard disk, so that you can play around with them. And this is what you can do. You can fork the repository locally. You can make the changes. You can edit the files just as you would your own project. And it's a much faster, iterating is much faster than it would be if you had to publish locally each time. And then having developed your build, having worked on modules and projects in a workspace, you probably want to share them with other people so they can use them as well. And it's just a one-liner. You run Fury workspace publish, and you give it a tag. And that's all you have to do. And that will push the repository. Remember I said that the build is always developed inside a Git repository. That will publish it to the accounts that you set up. So you do need to set up an account and choose a place to publish it, but it's very simple and takes seconds rather than potentially hours or, in my case, a year the first time. So these concepts I've been talking about, let's look at them in a little bit more detail. A workspace corresponds to a directory which has a build file and is basically a collection of projects. Each project is one or more modules. And a module is one run of the compiler. And we can think of a module as having a few standard inputs. It will have a choice of compiler, so which compiler we're going to run, some parameters for that compiler. It will have a class path, and it will have some source files. And that basically defines what the module does. And the output will be class files. And the class files from one module being compiled will feed into the class path of the next module. And we can form a graph from these. And the graph is between the modules, not between the projects. So are you OK with the idea of basically using a DAG to represent a compilation graph? And the view you had over, where is it? Over here. This is actually a DAG pretty printed for your benefit in understanding what depends on what. And as I showed before, workspaces can be published as Git repositories. So those are the three of the four main concepts in Fury. So let's look at these with an example. Here, the white rectangles are intended to be workspaces. The green squares are projects, and the blue dots are modules within those projects. And there are three projects here. Three workspaces, should I say, each of which contains one or two projects. Shapeless, Spire, and Cats, these are well-known projects in the Scala ecosystem, but they could be anything, really. And of those three, Shapeless needs to have dependencies on a plugin called Macro Paradise, and Cats needs to have a dependency on this plugin as well. So what we would like to do is import this workspace, the Macro Paradise workspace, into both Shapeless and Cats. And remember, that makes available the projects in that workspace to be dependencies of the modules in the workspace it's being imported into. So we can draw that like this. The orange arrows are dependencies. So this is the actually very simple in this case, compile graph. And the black arrows represent importing a workspace. Spire doesn't import the Macro Paradise workspace, and luckily we don't need a dependency on this module here. Okay. Now, one thing we could potentially do. Maybe you know or not, Shapeless, Spire, Cats, and another project called Monix, they're all part of a loose organization called Type Level. And Type Level aims to support various projects and does a very good job of that. And the projects in Type Level are very much intended to work happily with each other. So what Type Level might like to do is create their own workspace and to curate from a number of other workspaces the projects together in a nice, coherent workspace that has everything, all of the Type Level projects available. So the Type Level workspace itself wouldn't define any project. It's sort of empty, but it does import from several others. This is all speculative. These don't exist yet, but this is how it might be set up. And we could go a bit further. Type level could be imported into the community build along with Scala test, which is a popular testing framework for Scala. Scala test isn't part of type level, so it doesn't get imported in here, but it could go into the community build, which would be a larger workspace containing a lot of projects. And then what might be the what might be the easiest thing for you to do as a developer in your workspace is just depend on the community build. And we can assume that everything is nicely resolved in the community build, so we can just depend on any of the projects that are imported from up here. So this is hierarchy, and it forms a nice tree. So of the four main concepts, the one I didn't talk about much is schemas. Schemas serve a very particular purpose with Scala, because we often need to target different versions of the compiler. I mentioned that different releases that come out every couple of years are binary incompatible, usually source incompatible as well. So we'll often need to define different variations of the same build, maybe with slightly different sources, certainly with a different compiler, but maybe with other changes as well. And if we're developing a project which depends on very specific compiler internals, we can't rely on the major version of Scala, the ones that comes out every 2 years, being consistent. We actually probably need to depend on one of the minor versions that changes potentially every 3 months or so. Possibly we want to do other things like target a different backend. With Scala.js, we can target JavaScript. With Scala Native, we can target LLVM. And these are all variations of what will broadly be the same build. We might have dependencies on different versions of the same library, or even different libraries which do more or less the same thing. These are all what I consider variations, and the capability of working with them is through this feature called schemas. So they deal with cross-building, and each schema, you can think of it as a complete copy of the entire workspace. So that model I described earlier, where you have a workspace with projects, and the projects are modules, and if you remember back to the table I showed with all the details of all the modules, we're taking a complete copy of all of that, and we're going to tweak it in certain ways. We're going to create different variations so that maybe the compiler is different, maybe we add different sources, maybe a different commit hash from the same Git repository. These are all possibilities, and because it's a complete copy of the entire workspace, we can change any aspect of it. But typically, we want to be maintaining these in parallel. So why use schemas at all? Why not, if it is a complete copy of the entire workspace, why not just remove the concept of schemas and just have another workspace? A Scala 2.11 workspace, a Scala 2.12 workspace. Just keep them separate. The reason is that frequently we want to manage them in parallel. There are a lot of changes. Say we want to add a new module, which we probably want to make that same change to all of the schemas. If we're implementing some new functionality, our project probably wants those changes globally. So all of the Fury commands that you run, remember they're mutating this workspace, they can be made globally to all schemas, or you can specify an exact schema you want that change to be made to. So the reason is that the tooling is intended, or it's biased to change things in parallel, except when we really want to introduce a new variation. Another nice thing you get, and this is all because it's we're using a data-based format for representing the build. You can see a diff of any two schemas, just listing the differences between them. This is really useful for maintenance. Getting a good understanding of the build is something you can do just by querying it using Fury. So this is the same image I showed you before, but this was a little bit of a lie, because the dependencies between workspaces actually are between schemas within workspaces. So for each of these workspaces here, you can imagine that it defines potentially several different schemas, several different variations. And the schemas have names. The names are free form. You can call them whatever you like. There's no convention that you have to call a Scala 212 schema Scala-212. But I've just picked some names here. Most of them are Scala 212 because I've decided we're going to use the Scala 212 compiler. Macro Paradise depends on compiler internals. So in this case, we're naming it after the minor version, .4 and .7. That's a bit of a conflict, so we'll look at that in a second. We might call the schema latest, which always gives us the latest version, and by convention we would know that, well, if we didn't know by convention, then we could of course try it at any point. If it compiles, great. If it doesn't, then we have to go and look at which schema we depend on. So here's a closer look at that conflict I mentioned. Cat, in this example, depends on Scala 212.7, the Scala 212.7 schema of Macro Paradise, and Shapeless depends on the Scala 212.4 schema. And what that means is that the definition of the project and the module in here are probably different. Let's assume they're different. They've changed. This is what you would call diamond dependencies, where you have a project that depends on two other projects, and those two projects independently depend on a third project, but different versions of it. And we have a problem that we need to somehow linearize this into a single consistent class path. And if we have two different versions, we can't do that. There will be, if we include both, then one will shadow the other, and you'll get all sorts of problems. And Fury will enforce that you actually resolve this. So what it requires you to do is basically select one or the other. Within a workspace, and this is a requirement before you publish a workspace, every project name must uniquely resolve to a consistent version of that project. That's one very important constraint. And this happens at every level. So if we just go back here, type level must resolve all of the projects so they uniquely refer to a single definition that is the same across all of them. We can always test this by compiling them, but we can define a Macro Paradise project down here that is a copy of either the 212.7 version or the 212.4 version, and define that in such a way that it compiles both Shapeless and Cat. Hopefully that's possible. There's no silver bullet for fixing it for all different different projects with different sources that maybe or maybe not API compatible. But it gives us the means and the tools to resolve those conflicts. Worst case scenario, maybe we have to check out the source of Macro Paradise or check out the source of Shapeless and manually change the source to use the new API or to provide for an old API. It might not be the best solution, but it becomes possible where it wasn't easily possible before. So let's quickly talk about publishing. I did cover this a little bit before. You can't actually publish to Maven Central with source dependencies. It needs binaries. We could compile everything, wrap it up in a fat jar, and publish that to Maven Central. But if everybody did that, we would end up with even more problems where we end up with huge class paths and more conflicts as the whole dependency tree from one project clashes in some way with the whole dependency tree of another project. So that's not really a solution. My proposed solution to this, once again, is to use schemas. And I see a binary schema as just another variant of the build. So we can be happily developing our different schemas for Scala 2.11, 2.12, and so on, based entirely on sources. But maybe we can maintain another version, another variant alongside that, which depends on binaries. It replaces all of those source dependencies with binary dependencies. Now, it's up to us to resolve those. It might not be possible because the things we depend on aren't published yet, so that the schema doesn't have to be consistently working. But we can use schemas once again to publish to Maven Central. So let's talk very, very quickly, I've only got 5 minutes left, about support for Fury. Propensive, as well as being my Twitter handle, as you can see up there, is the company I've been running for the last few years. What Propensive does, it provides training in Scala. I organise a conference called Scala World, where we go hiking in the Lake District before having some talks. And I develop open source software such as Fury for Scala. And of these 3 things here, the first one earns me money. The second one breaks even. And the third one, developing open source software, is a massive drain on all of my resources. So, what is Propensive going to do to support Fury as a small company? A small company that is basically just me. When adopting a new tool, it's a leap of faith at the best of times, let alone when it doesn't have a viable company around it. Someone told me that Google has 50 engineers working on Bazel, and I think Gradle maybe has a similar number of people. I can't compete with that. Yet I want to give you confidence in my tool. So I'm making steps, hopefully, in the right direction, because I have a new partnership which will begin at the start of next month with Virtus Lab, who are a company based in Krakow in Poland. They have over 100 developers, vast experience working with Scala tooling. They organize a tooling conference each year, which is an excellent event. It's also a great excuse to come to Krakow, which I can recommend. And they're going to give me a small team of people to work on Fury, which I am absolutely delighted about. To have a project which I've developed entirely on my own and suddenly get support from a company like Virtus is amazing for me. And I'm going to give them all the worst tasks that I don't want to do as thanks. So support for Windows, profiling, performance, more testing. I need more testing. The ability to export to SBT. One thing which can give you confidence in a tool is if you have an exit strategy. And it's easier to adopt something if you know there's a way out if it doesn't work out for you. Publishing to Maven Central, implementing the build server protocol, which is a bit like LSP for IDEs, but for builds. Fixing bugs, and developing the various libraries I have. Magnolia, Contextual, Kaleidoscope, and several others. On my to-do list, I've got some code cleanup to do, support for Scala.js, Scala Native, and I'd like to support Kotlin as well. It's a JVM language. We can work with Kotlin, and I'm going to speak to JetBrains about that soon. Support for things like code coverage, benchmarking, and I've created some issues on GitHub, on the Fury GitHub page. And then I'll get to work on converting the ecosystem to use Fury, along with Virtus Lab. So just to quickly wrap up with some details of the roadmap for Fury. The private beta was opened earlier at the end of last month. And the source code, just a few days ago in San Francisco, I announced that. So that's now on GitHub. I'll start working with Virtus Lab on these changes. And the goal is to publish version 1 in the first quarter of next year, which will synchronize with Scala 2.13, the new version of Scala that's coming out. If you're interested and want to sign up to the private beta, you can go to my website at propensive.com and follow the links to Fury. And that is all I have. Thank you. Do I have time for questions, or did I exhaust my my time slot?
Right, guys. we can have a quick question. Any other interaction with John will have to be done via the Hoover app. You're on the Hoover app.
I don't.
The answer is yes.
Yeah. Okay. Or you can find me outside.
Or his Twitter handle, or outside. But we can slip in with a little bit of butter a question. Who's got a question for John?
Hi, John. Thanks for the talk. When do you compute dependencies and download dependencies yourself? I mean, as in Fury itself, or do you use an external library for that?
So thanks for the question, Christoph. For binaries, I use an external. I use Corsair.
No, sorry for.
So for binaries, I will use Maven Central. So you can depend on Maven Central binaries. It uses Corsair to download them, which is pretty quick. Obviously, for the source dependencies, it will go and fetch Git repositories automatically, clone them, check out the right commit. Does that answer the question?
Yeah. Thank you. Any particular reason for choosing this library over Ivy or Maven Ether or something like?
For choosing which library?
Corsair?
Corsair.
Yeah.
Corsair was chosen because it's significantly faster, and Corsair was written as a response to Maven and SBT's very slow downloading, and it's remarkably fast in comparison. So that was the reason.
Okay,
yeah.
Thank you very much.
Now, in the last couple of talks, we had Thomas from Thessaloniki via London, or is it the other way around, talking about category mathematics in coding, and now we've got John talking about Scala, which, I mean, how many of you use Scala? Go and show. Right, okay, so...
Is it more or fewer than before?
You know,
I asked the question at the beginning.
It's not pop, is it? But from little acorns, the mighty oaks grow.
I think so. It's also everything I've shown you isn't really limited to Scala. All of these dependencies could be Java or Kotlin dependencies. If you're Kotlin users and want an alternative to Gradle, then maybe this could be it.
And of all the languages that have ever been used for coding, I mean, there are a lot of them have disappeared over the years. Is this something that you can see that Thomas said in the last speech that about the category mathematics and how it was a great idea 30 years ago, but now it's coming to fruition and now it's becoming applicable. What do you see the timeline on your project here? Hopefully not 30 years.
No, I will. I don't know where I'll be in 30 years' time, but I anticipate that it's going to be critical over the first few months after the release. I'm planning the release in sync with Scala 2.13, which will mean there will need to be for people using SBT, the old way of doing things, there will be the entire ecosystem very slowly republished for the new version of Scala. And Fury can kind of have a race with that. We can publish things faster. I mean, there's maybe more work involved in people learning how to use Fury, but we can get things out the door faster. And that's where I hope to get a lot of the uptake early on. If we can have projects converted to Fury by anybody, it doesn't have to be the project maintainer, then that can bootstrap the ecosystem. And once it's reached that critical mass, at least for Scala, I think it could move forward very quickly.
Well, I think that's a clear message. Guys, you've got to start getting furious. These things are not going to grow without you adopting. So that's your move. Take hold of it, do what you can with it, and we'll see what we can make from it.
Yeah.
Right. Now, hold on a minute, because
okay.
I got to get up here. Right. Now, you said to me before that you don't get back to the UK very often.
I don't, no.
Now, hands up, who hasn't seen the film Leon? Right, okay, there's one of you over there, and you were very brave to admit it. Leon, the international assassin. Do you remember what he carried around wherever he went? It was an olive tree. I'm sure it was an olive tree, wasn't it? Is there anybody going to argue with me? No, I didn't think so. No. So, there you go.
Thank you very much.
John Pretty, international, furious assassin, is going to be, you'll know him by his pot that he will have with him, with his Thessaloniki.
I'll set it on the windowsill as soon as I arrive.
Yep. And you will know him by the trail of coded. I ran out of verbs there.
Thank you. Thank you, David.
Thank you very much.
Thanks.